We're going to take another crack at looking at those light and reflection practice problems from the other day, the ones that were giving your teacher such a hard time. And so, let me hide this stupid thing. Can I hide this thing? You're not going to let me hide this thing. That's fine. That's really okay. So as you can see right here, we're going to be looking at problem 1, problem 2, and then we're going to skip down and do number 5 and number 6. And then we're not going to worry about 3 and 4 because they're evil. 7 and 8 are also evil, and I think we can get through enough math without resorting to the truly evil stuff for y'all to be able to get how this works. Remember that this is not going to be for a grade, so it's just important that you know how to do this, because what we're doing here is going to apply when we start looking at lenses. The same kind of math, same kind of reasoning applies there. I'm going to just start off and jump into problem number 1. So let me slide a couple things around here. All right. I'm going to shrink myself way down because I really don't care if I see myself or not. Problem number 1, in Alaska, the top of Mount McKinley has been seen from the top of Mount Sanford, distance of 370 kilometers. An object is basically 370 kilometers from a giant concave mirror. So if the focal length of the mirror is 250 kilometers, what are the object's distance and the magnification? So let me get some paper up here. The nice thing about this is, for the most part, we don't have to worry about having our lengths in specific units so long as we are consistent with all of our units. Equations that we're going to be using here today, 1 over focal length is equal to 1 over the distance of the object plus 1 over the distance of the image. We've got that our magnification is equal to the distance of our image over, hold on, actually it's equal to the negative distance of our image over the negative distance of our object. And it's also equal to the height of our image. Am I recording? Just making sure. Yes, John King, I am recording. As far as I know, over the height of my object. So let's take what they give us in the problem right here. They give us the distance of the object, so we know that our DO is equal to 370 kilometers. We know the focal length of our mirror is 250 kilometers, so F equals 250. They want us to find see, I'm thinking that that is still a typo right there. They're wanting us to find the image distance, not the object distance. So we're looking for DI. That's probably why we were confused the other day, is because that is a straight up typo. And they also want us to find the magnification factor. So we're going to start off by finding DI first, and we're going to use this first equation up top, where 1 over focal length equals 1 over the distance of the object plus 1 over the distance of the image. Since we're looking for DI, we're going to get DI on its own side by subtracting 1 over DO on both sides. So 1 over F minus 1 over DO equals 1 over DI. Okay? Again, if I'm going too fast or if you've got a question, type it up in the chat or try and wave at me. At this point, I'm going to go ahead and plug in some numbers. And you hear my dog barking at nothing in the backyard. So I've got 1 over 250 minus 1 over 370 equals 1 over the distance of my image. Now at this point, I'm going to plug this into my calculator and see what number it spits out. So I'm going to go 1 divided by 250 minus 1 divided by 370. The answer my calculator gives me is about 1.297 times 10 to the minus 3. But remember, that's not my answer. That you could probably invert your equation, okay? But this works just as fast, and the less I'm flipping things around, race, the less likely it is that I'm going to confuse something. So if I keep in mind that this is 1 over di, then I can find di by just taking 1 divided by that answer. And so the distance of my image, according to this, is 770.83, and I forgot a 0 in there, 770.83 kilometers. So that's answer to the first thing over here, 770.83 km. Now to find our factor of magnification, since we already have our DO and our DI, I'm just going to use the first part of this equation right here. Hey! Shut up! And I'm going to put M equal to negative DI over DO. So that's going to be negative 770.83 over 370. So since I've still got 770.83 in my calculator, I'm going to do that divided by negative 370. And I get a magnification of negative 2.08. Negative 2.08 is my mag. And that's problem number 1. Okay, not as bad as we were afraid it was going to be, I think. I'm taking a minute and pointedly looking at my chat window to see if anybody has any questions. Three, 2, 1. Okay. So if y'all are okay with that one, let's take a look at problem 2. Okay. So between the screwed up key, we're going to go ahead and add number 2 to the evil list. And we're not going to worry about that because they're sending us mixed messages. So you have just gone from having to worry about 4 problems to having to worry about 3. Let's skip number 2. Also skipping 3 and 4, let's sally forth to number 5. Number 5 and number 6, if they're written correctly, they should be decidedly less evil. So let's take a look at 5. See, I don't feel quite so bad. I mean, I know that there's some of this junk that I am just not super familiar with, and it's hard for me to kind of keep everything straight. But if they're feeding me bad information, it is not all my fault. And I don't know, I feel better about that. So let's look at number 5. Number 5, we've got a stalagmite. It's 32 meters tall. By the way, do y'all remember how to tell the difference between a stalagmite and a stalactite? Okay, math is dumb. Yeah, you're right. You're right. Don't tell Sandy I said that though. Have Slef confidence. Yes, I am very confident in my Slef. Yes, one of them does come from the floor. So the way that I remember it is a stalactite has a T in it, and the T looks like a thing that's kind of hanging down, like that. Okay, if I have like my cave wall. Stalagmite has an M in it, and that looks like things that are kind of poking up from the ground. So there you go. Okay. So if we've got a stalagmite that's 32 meters tall, it can be found in a cave in Slovakia. Okay? If a concave mirror with a focal length of 120 meters is placed 180 meters from this stalagmite, How far from the mirror will the image form? What is the size of the image? Is it upright or inverted, real or virtual, regular or decaf? Let's take these one at a time here. Okay, so let's put down what it is we definitely know about this stalagmite. We know that the height of our object is going to be 32 meters, right? Stalagmite is our object. We know focal length is 120 meters. We know that it's placed 180 meters away from the stalagmite, so that tells us the distance of our object. So DO equals 180 meters. Now let's talk about all the things they want us to find here. They want us to find how far from the mirror will the image form. So how far from the mirror is going to be DI. We don't know that yet. What is the size of the image? That's going to be HI. We don't know that yet. Is it upright or inverted, real or virtual? You know, we can go ahead and answer those right now, okay? Because if we've got a concave mirror, right? Concave mirror means that it's curved like this, and so if we've got our stalagmites facing up like that, then the light rays coming from there are going to be focused back through our focal point, which means that we're going to have upside down images. Okay, so our image is going to be inverted. Since it's actually made by real light rays crossing, we know it's going to be real. So I'm going to go ahead and pencil in real and inverted. If that's giving you a hard time, go back and take another look at your notes. We will be talking about those terms some more later on. So don't panic about it too much just right now. Let's worry about these other things we need to find here. So we need to find distance of our object, distance of our image and height of our image. We know distance of object, we know height of object, we know focal length. So let's start with the equation that says 1 over f, 1 over our focal length is equal to 1 over the distance of our object plus 1 over the distance of our image. So we're looking for distance of image. Let's do like we did on one of those problems. I think it was problem number 1, the one that made sense a little while ago. And let's isolate this by itself. So we're going to say that 1 over di equals 1 over f minus 1 over do. At this point, we can start plugging in some numbers. So that's going to be equal to 1 over 120 minus 1 over 180. So when I plug that into the calculator, I'm going to wake the calculator up. I'm going to say 1 divided by 120 minus 1 divided by 180. That gives me a ridiculously small number, but I also need to remember to invert that because that's 1 over di. So if I do 1 divided by my answer, oh, that's handy. So it tells me that di is going to be 360 meters. Okay, piece of cake. So that's one thing down. Yay. Now, how to find the height of our object? Okay, remember, excuse me, that, I've got it over here. That height of our object, height of image over height of object. So high over ho equals negative di over do. Okay, Sierra Penfold, if you are just joining us in the middle of things, I apologize. I am taping this, and I will have the entire thing playing. If you've got a specific question, feel free and type it in. We're working number 5 on the light and reflection practice problems. So let's take what we know. We know that we've got high, we've got ho, we've got negative di, and we've got do. we could just plug things in and cross multiply. Yes, we are also no longer doing number 2 because number 2 is evil. Thank you, Gentry. It made us think it was nice, but it was really a big jerk. And trust me, it takes one to know one. So we could plug these in and cross multiply to find the one that we need, which is hi. We could also rewrite this equation to get hi by itself, and that would be easy enough. That would just be multiplying both sides by ho. So if you want to say that hi is equal to negative di times ho over do. Hi, dihodo. I'm sorry, that's silly. I don't understand why you multiplied and divided to get 360. Okay, so check it out. I'll back up and we'll talk about that. So we're trying to find distance of our image, right? So we use this equation right here. And I just plugged in 120 for f, 180 for do. And if I do 1 over 120 minus 1 over 180, then I get 1 over 360. But my calculator doesn't let me know that it's 1 over 360. It's some kind of weird, like 2.7 something times 10 to the negative whatever. And so I inverted that to get what the di was. And I did that just by taking 1 divided by the answer that it gave me, which is how I got that 360. So using a method of your choice, if you want to cross multiply to find hi, you can. I'm not sure how that negative in there is going to throw things off. You might just go ahead and assign that negative to that di right there. I'm going to do it this way because oh, you're very welcome. Am I multiplying di and ho in that fraction? I am multiplying di and ho and then dividing by do, and I'm making sure that that whole thing's negative. So if I plug in, that's going to be negative 360 times 32 over 180. Now 360 over 180, that's easy, right? That's the same thing as 2 over 1. So if I do 2 times 32, that gives me 64, and that would give me negative 64 for the height of my image. That sound about right to y'all? Okay, so let's go ahead and say that our height of our image is negative 60, I can't write, negative 64 meters. I did that in my head, so feel free to check my math and see if I did it wrong. And so we were correct. Remember, if it's got a negative height, that means that it's inverted. So what started out as a stalagmite now looks like a stalactite, okay? That's twice as big or twice as tall as the original. This is an excellent place for me to take a quick break and ask for any questions. Y'all doing okay? When you cross multiply, do you not have to do it both ways? Okay, so if I cross multiply Aiden Bolden, to find hi, I'm still going to be taking this times this divided by that, right? So ho times di divided by do, which is exactly what I did right here. Ho times di divided by do, and not forgetting that negative. So really, it's the same exact thing. It's just different way of looking at it. They taught you cross multiplying to solve missing things in an equality of a fraction back when they taught you that. This is just algebrating the same thing, I guess. Any other questions? Okay, last one. Then you guys can go break and have a snack or jump in the pool or something. I don't know. Let's look at number 6. The eye of the Atlantic giant squid, which I guess is a thing. 1 act. Oh, yeah. I'll have you guys out of here before 1 act, and if you have to run early, remember, I'll post the videos, so don't panic. The eye of the Atlantic giant squid has a diameter of 5 times 10 squared millimeters. Let's just say 500 millimeters. I hate when they do that. If the eye is viewed in a concave mirror with a radius of curvature equal to the diameter of the eye, and the eye is 1 times 10 cubed millimeters, or 1,000 millimeters from the mirror, how far is the image from the mirror? What's the size of the image? Is the image real or virtual? So lots to chew on right there. Let's take it apart little piece by little piece here. Let me get a fresh piece of paper. Okay. Let's talk about this squid, and let's talk about what they've given us. Okay. So this diameter of 500 millimeters, that's going to be, I'm going to call that the height of my object. Okay. So HI equals 500 millimeters. I hope it's okay with you guys if I go ahead and get rid of that scientific notation crap. If the eye is viewed in a concave mirror with a radius of curvature equal to the diameter of the eye. Okay. So now they're trying to throw word tricks at us. Let's go ahead and write down that the distance, wait, that would be HO, not HI. Oh, somebody's posting photos. Distance of my object is going to be 1,000 millimeters. King, it's HO. Yes, thank you, Jaren. I caught it. Appreciate you. And so if they're saying the radius of curvature is equal to the diameter of the eye. So here's what we're going to do. We're going to look at R. Now R, if you remember, if you've got a mirror, if you imagine that that mirror is part of a larger sphere, and that is a very eggy-shaped sphere, I know, sorry about that, but the mirror is part of that, then the radius is going to be the distance from here to here, okay? Just like in any other circle or any other sphere. The focal point, remember, is halfway between the midpoint and the outside. So whatever they give us for radius, we can just take that and divide by 2 to find our F. Okay, so if it says this right here is equal to the diameter of the eye, so the diameter of the eye is 500. Therefore, R divided by 2 is going to give me F. So if F is R divided by 2, 500 divided by 2, that means that my focal length is going to be 250, right? Millimeters. So we can forget about this business here because we don't care anymore. And so we're going to, let's see what all they want us to find. They want us to find how far is the image from the mirror. So they want us to find the distance of the object. They want us to find what's the size of the image. So they want us to find, oh, Jaren, I'm way ahead of you. That's DI. I know. Thanks. All right. That's why I pay you the big bucks. Keep me on the straight and narrow here. How far is the image? So that's going to be, what size is the image? That's going to be HI. And then is the image real or virtual? Again, we're looking into a concave mirror here. So it's going to be inverted and it's going to be real. So I'm going to go ahead and write real here. I'm going to spell it wrong because that's how I roll. You don't get to tell me what to do, Jaren. So let's start off with our 1 over F equals 1 over DI over plus 1 over DI plus 1 over DO. And again, we're going to flip it to where we can get DI by itself. So 1 over DI equals 1 over F minus 1 over DO. So Race, I know you've asked about inverting these. I don't know if inverting these because we're subtracting would actually work. So I'll let you play with that and find out if you're really curious. I'm really not. So let's carry on here real quick. You'll have play practice to get to. So let's go ahead and plug in what we have. We have 1 over 250 minus 1 over 1,000. So 1 250th minus 1 1,000th. Wouldn't that be the same as 4 250 or 4 1,000ths minus 1 1,000th? So we'd get 3 1,000ths. I'm going to kind of put that over here, just in a bubble, just in case that's a thing. I'm going to plug this into my calculator. 1 divided by 250 minus 1 divided by 1,000 gives me 3 times 10 to the negative 3. And so when I invert that by doing 1 divided by my answer, I get 333, which is just about 3 1,000ths. So the DI is going to be equal to 333.33 millimeters. Okay? Okay, maybe it will. But see, note, if I was to flip that, that would be 250 minus 1,000. That would not give me the same thing. That would give me like negative 750. So I don't know why that's a thing, but that's a thing. Ask your math teacher. So we've got DI. Now let's go find our HI. And we can do what we did a while ago where we've got, I keep losing that. We've got HI over HO equals negative DI over DO. Again, we're looking for HI, so we can do our cross multiply and divide thing again, which is negative of HO times DI. OD over DO, negative. So we plug that in, so it's going to be negative of 500 times 333.33 divided by 1,000. 500 1,000ths, that's like 1 over 2, so 333.33 divided by 2. That's going to be like 167 point something, I think. Yeah, I get 166.665. So the height of our object is 166. Oh! Almost forgot about the negative. So it's going to be negative 166.67 millimeters. And it's negative, and again, that tells us that it's real, but it's also inverted. Okay? So that takes us through that paper. Thank goodness. If anybody is really deeply bored and you want to go back and try and take care of 3, 4, 7, and 8, I'm not going to stop you, but I'm also not going to expect you to do the same. So, you know what? You guys keep politics out of the chat. That's very not nice. Does anyone have any last-minute questions before I bring this one to a close? Again, thank you so much for tuning in today. Sorry about the kerfluffle. Oh, what do we exactly turn in? You're not, oh, you mean if you don't turn this in, what will you be turning in? I will let you know when we get there. Okay? Anybody else? Questions? Sierra, I don't mean to make light of things. I'll post in the Google class exactly what it is I want y'all to turn in for me. Just want to, no, you don't turn this in. Why would I have you turn this in? I just worked these all. It's practice. I'm sorry. I'm feeling feisty. I miss seeing you guys' faces. I can't sass you to your face, so I have to do it to a camera, which is nowhere near as satisfying. Just a reminder, tomorrow morning I'm going to be, during the 10 o'clock to 11 o'clock hour, I'm going to be talking about lenses and magnification and refraction and stuff like that, which is not going to be too much different than what you've seen with mirrors. You are big brain. Yes, big brain is you. So until I see y'all again, if you have any questions, shoot me a message or hit me up in the Google class. Otherwise, peace out. I say, and I don't know how to stop this thing. There we go. And end meeting. Let's stop